Hello, future engineers, subscribers, viewers, and students. Here is another video in structural analysis, and this is the second part of my presentation on solving beams by superposition method. So determine the external reactions to the supports by the superposition method. EI is constant. So here is the given beam, and I want you to check the moment diagram by parts for its loading and for the reactions. So for the loading, for instance, for this loading here, 1/2 of 5 times 30 times 5/3 is 125, and it is a third degree curve. For 18, we have at B, 18 times 4 times 2 is 144, second degree. And we imagine a concentrated load at B and a couple at B of 144, so that's why it's extended. 18 times 4 is 72. 72 times 5 is 360. And we have here a couple 180. This is it, rectangular. And for the 26 kilonewton. So at various points at B, 78. At C, 234 kilonewton meters. At B, 338. And at A, 468. So these moment values are supposedly over EI, and since EI is constant, we just imagine it is equal to 1. So EI, deflection at B due to the loads, so 125 quantity 5 square divided by degree 3 plus 2 for the deflection at B. Then only these moments will have uh, deflection effect at B. So for the couple, 144, then 5 square over 0 degree couple plus 2. Then for this moment diagram, 360 moment at the wall, length 5 square, it is first degree plus 2. We proceed to the moment due to the couple, which is only this part, 180, length 5 square, divided by 0 degree plus 2. And for this 26 kilonewton load, we have here trapezoid. Imagine 338 couple, 338 length 5, so 5 square over 0 degree plus 2. Then 468 minus 338, we have additional moment here, which is equal to 130. 130 is 468 minus 338. Then length 5 square divided by degree 1 plus 2. Computing EI delta at B due to the load is 38950 over 3, and that's downward. Anyway, we will not put signs, we just equate deflection at corresponding points, then you just equate later. Next, due to reaction at B, this is the moment diagram due to the reaction at B, moment diagram due to the reaction at C, moment diagram by parts due to reaction at D, and moment diagram by parts due to reaction at E. So for this moment 5RB, length 5 square, only this portion of the moment diagram by parts will have effect on the deflection at B. So 5RB, 5 square over first degree plus 2. Then for RC, we have a couple of magnitude 4 RC, and due to concentrated load, 9 RC minus 4 RC is 5 RC. So for the couple, quantity 4 RC times 5 square divided by 0 degree plus 2. Then for the concentrated load, which is moment at the wall, will be 5 RC, length 5 square over degree 1 plus 2. For D, we only consider this moment diagram. For RD, we have a couple of 10 RD, and due to concentrated load of 15 RD minus 10 RD, so 5 RD. So for the couple, quantity 10 RD, length 5 square over 0 degree plus 2. And for the, due to the concentrated load, moment at the wall is 5 RD, length 5 square divided by first degree plus 2. So that's for RD. Next for RE, so it is just this portion. We have a couple 16 RE and 21 minus 16 is 5 RE due to moment at the walls A, at the wall at A due to the concentrated load, which is RE. So for the couple quantity 16 RE, 5 square over 0 plus 2. Then for 5 RE, 5 square over first degree plus 2. Simplifying and equating it to 38950 over 3. So we have 125 over 3 RB plus 275 over 3 RC plus 400 over 3 RD plus 725 over 3 RE equals 38950 over 3. Call that equation 1. Next, EI delta C due to the load. So we only consider this moment diagram by parts from A to C. So we begin with 5RE. The effect would be deflection. And because we have a slope here, the additional deflection is equal to 4 times theta at B. Then theta at B is moment at the wall 5RB, length 5 divided by first degree. First, sorry, this one. Sorry, this one. We only consider moment diagram by parts from A to C. So 125, 5 square over third degree plus 2. And due to the additional deflection because of the slope at B, we have uh, 4 theta, because that's 4 meters to C. 4 times quantity 125 times 5 over third degree plus 1. So EI delta C due to the load is 125 square over 3 plus 2 plus 4 times 125 times 5 over 3 plus 1. For the next load, which is this, so this has effect because this is part of ABC. So this is 144 length 4 square over degree 2 plus 2. Then due to this couple, 144 times length 5, so 5 square over 0 degree plus 2. Then because the end is at B, there is additional deflection due to that couple there, which is 4 times the slope here. 4 times 144 times 5 over 0 degree plus 1, which is this 4 times 144 times 5 over 0 degree plus 1. Then for the additional moment, which is 360, take note we are computing delta C. So for the load, for the deflection due to this moment, 360 5 square over first degree plus 2. Then for the additional deflection due to slope at B due to this moment is 4 times 360 times 5 over first degree plus 1, which is that. Then for the couple load, which is this, it is just 180. 180, length is 9, because that's 5 plus 4, 9, 9 square over 0 degree plus 2. And for this concentrated load, we consider this part. So we have a couple 2, 3, 4 up to C. And due to concentrated load, the moment due to concentrated load at A is 468 minus 234, so it's also 234. So for the couple first, 234, length is 9, so 9 square over 0 degree plus 2. And for the concentrated load 234, where 234 here is 468 minus 234, length is 9, so 9 square over first degree plus 2. So that's it. Computing AI delta C due to the load is 36191. And due to the reaction at C, so we consider these moment diagrams from A to C. Beginning with this load, it has two effects, deflection and due to slope. So AI delta C due to reactions is 5 RB, length 5 square over first degree plus 2, that's due to deflection. Then slope 4 times quantity moment 5 RB, length 5 over first degree plus 1. So 1 plus 1. Then due to this reaction, RC, so it is 9 RC at wall A. The length is 9. So it is just 9 RC, 9 square over first degree plus 2. That's for R sub C. Then for RD, we have to consider this. We have a RD, and due to concentrated load, the moment of the wall will be 15 minus RD, so 9 RD. Deflection at C, 6 RD, 9 square over 0 degree plus 2. And for the concentrated load, 9 RD, 15 minus 6, 9 RD, length 9 square over first degree plus 2. So that's for RD. Then for RE, so we consider this, we have a couple 12 RE and 21 minus 12 RE is 9 RE. So for the couple, 12 RE, 9 square over 0 plus 2. And for the concentrated load, 9 RE, 9 square over first degree plus 2. So simplifying and then equate to 36191. So we have 275 over 3 RE RB plus 243 RC plus 486 RD plus 729 RE equals 36191. 36191. So next is let's compute EI delta D due to the load. So due to the load, on the next slide. So let's continue. So this time, let's evaluate EI delta D due to the loads. So we consider moment diagram by parts to D. So beginning with this, deflection and due to additional deflection due to the slope. So EI delta D due to the load, take note these were the first two equations. L delta D due to the load is 125, 5 square over 3 plus 2 plus slope 10 times theta, because that's 10. So 10 times 125 times 5 over third degree plus 1. So that's for this moment diagram. For this moment diagram, this has two effects, deflection and slope, which is 6 times the theta here. So deflection first, 144 times 4 square over second degree plus 2. Then slope is 6 times moment, 144, length 4 divided by second degree plus 1. Then for this couple here, deflection 144, 5 square over 0 plus 2. Then for the slope, 4 plus 4 plus 2 is 10. So 10 times moment 144, length 5 over 0 degree plus 1. Then for this moment 360 times 5 square over 1 plus 2 due to deflection, and due to slope plus 10 of theta here, 10 times 360 length 5 divided by first degree plus 1. Then for the couple load up to D, so it's only up to here, but we have to extend by the additional deflection by slope. So 180 times 4, 4, 35, so 13. 180 times 13 square over 0 plus 2 due to deflection, plus additional slope 2 times theta, because that's 2. 2 times moment 180, length 13 divided by 0 degree plus 1. Then for this moment due to 26 kilonewton load, so we have a couple of 78, and due to moment due to the concentrated load of 26, which is 468 minus 78, and that's 390. So for the couple due to deflection at C, 78, the length is 5, 9, 13, 15. So 78, 15 square over 0 degree plus 2. And plus 468 minus 78, 390, 15 square over first degree plus 2. Simplifying, EI delta D due to the load is 82,830.5. Then, due to reaction, so we consider this moment diagrams from A to D. Beginning with this, there are two effects, deflection and due to slope. So, EI delta D due to reactions, 5 RB times 5 square divided by first degree plus 2. Then slope 4, 4 plus 2, 10. 10 times moment, which is 5 RB. Length, which is 5 divided by first degree plus 1. Then for this moment diagram, there are two effects again, deflection and slope. Slope is 6 times the slope at this point. So 9 RC, length 9 square over first degree plus 2 for the deflection, then plus 6 of moment 9 RC, length 9 over first degree plus 1. So that's for R sub C. Then for RD, it is just 1 because it occurs at D. So it is 15 RD, 15 square over 1 plus 2 for the deflection only. Then for RE, we have a couple 6 RE, and due to concentrated load, which is 21 RE minus 6 RE, so 15 RE. The effect is would only be deflection at D. So for the couple, 6 RE times 15 square over 0 degree plus 2. Then for the concentrated load, 21 minus 6 is 15 RE, then 15 square over first degree plus 2. Simplifying and equating it to 82,830.5, we have 500 over 3 RB plus 486 RC plus 1125 RD plus 1800 RE equals 82,830.5, equation 3. Then finally, EI delta E due to the loads. So beginning with this, deflection is 125, 5 square over third degree plus 2, plus slope 4 plus 4 plus 2 plus 3 plus 3, that's 16. So 16, moment 125, length 5 over third degree plus 1. Then for this loading, for this moment rather, second degree, so 1 4 due to deflection, 144, 4 square over 2 plus 2. Then due to slope, the additional deflection moment, it is 4 plus 2 plus 6, that's 12. So 12, moment 144, length 4 over second degree plus 1. Next, for this couple here at B, moment due to deflection 144, 5 square over 0 plus 2. That's it. And due to slope 8, so 10, 16. So 16 of 144, length 5 over 0 degree plus 1. And due to this 360 kilonewton meter moment, due to deflection 360 times 5 square over first degree plus 2. And due to slope, that's 16 again, 16 of the theta here. So 16 times 360, length 5 over first degree plus 1. Simplifying, I delta E due to couple, I forgot. So there are two effects. Deflection 180 times length 13 square over 0 plus 2. And for the slope, additional slope is 2 plus 3, that's 8 of theta. Theta is 8 times 180. 8 times 180 times length, that is 13, divided by 0 degree plus 1. Then due to this moment diagram here at this end, due to deflection, we have 468. The length is 18. So 468, 18 square over first degree plus 2. And due to slope plus 3 theta. So 3 times 468 times 18 over 1 plus 1. Simplifying, EI delta E due to the loads is 133,835. Then due to reactions, we have 5 RD, 5 square over first degree plus 2. Then due to slope, 16 of 5 RD, length 5 over 1 plus 1. So that's for RB. For R sub C, deflection and slope. So 9 RC, length 9 square over first degree plus 2. And for the slope, 6 plus 6, 12 of 9 RC times 9 over 1 plus 1. Then for RD, which is this, you have deflection and slope, 15 RD times 15 square over first degree plus 2. Then plus 6 times theta. 6 times 15 RD, 15 over 1 plus 1. And finally, for RE, is the moment diagram. So it is moment at total 21 RE, length 21. So 21 RE, 21 square over first degree plus 2. Simplifying and equating it to 133835. So the fourth and final equation would be 22725 over 3 RP plus 729 RC plus 1800 RD plus 3087 RE equals 133835. Solving these four equations simultaneously using your calculator, we obtain the following. RB is 80.268 kilonewtons. R sub C is negative 18.140 kilonewtons. R sub D is 50.782 kilonewtons. And RE is 11.745 kilonewtons. Now for the rest of the reactions, AY, MA, moment B, moment C, moment D, I want you to solve that by statics and confirm these answers. So AY equals 48.348 kilonewtons. Moment at A is negative 30.580 kilonewton meter. MB is negative 38.839 kilonewtons meter. MC is positive 31.627 kilonewton meter, and finally MD equals negative 7.532 kilonewton meters. So that's it for this video.